Okay, guys, so let's do another problem like question 4 or 5, I'm sorry, on worksheet 7.2. Only this time, instead of having something that is, oh goodness, sorry, that is an unknown substance, I went ahead and just made it water so that we know the values for everything. So first thing I do is I start a data table so I understand what's going on, and I draw a sketch. I see that I have water, so I know it's H2O, and it is going to go from a negative number past the boiling point. So I'm going to start here at negative 23.1 degrees Celsius, and I'm going to take it up to 0 degrees Celsius, and here I have a change of state. And now I'm still at 0 Celsius, but going from the solid to the liquid, so this is a phase change. Then I bring it up to 100 Celsius, where it becomes a gas. So now it's going from a liquid to a gas. And then after that, it will heat up to 120.1 degrees Celsius. So I'm going to have a Q1, a Q2, a Q3, a Q4, and a Q5, all for water. And I know what Q total equals. Q total equals 121,000 calories. And I want to know what mass. So my question is mass. And so each one of these is going to have an X in it. So Q total is going to equal Q1 plus Q2 plus Q3 plus Q4 plus Q5. So how are we going to do this? So Q1, I have a change in temperature, and so it's going to be mass times change in temperature times C sub P. Here I'm doing a change of phase, so that has to be mass times delta H. And since this is at the freezing point of water, that would be fusion. Plus, now I have another temperature change, so it's mass times C sub P times delta T. Plus, here I'm going from liquid to gas, so now this is a change of phase, and it's going to be mass times delta H, but now we're going from liquid to gas, so this is vaporization. And then the last one is another change in temperature, mass times C sub P times delta H. So I need some values from the book that are actually your worksheet, and delta H, or C sub P for ice is 0.05, so this is going to equal X times change in temperature here is going to be final minus initial, which will be 23.1 degrees Celsius, and C sub P is 0.50, and that's calories per gram degrees Celsius, plus mass, which is X. Heat of fusion for ice to water is 80.0 calories per gram, plus X times C sub P for water, which is 1.00 calories per gram degrees Celsius. And the change in temperature here is going to be from 0 to 100, so that's 100 degrees Celsius. And that would have at least 3 significant figures. So I've got C sub P1, or Q1, Q2, Q3, so I'm on Q4, which is plus X times the heat of vaporization, which is 540 calories per gram, I'm going to write the next one down here so I don't run off the edge of the page. And the last one has another change of temperature. And I still don't know my mass. My C sub P for steam is 0.48 calories per gram degrees Celsius. And my temperature change is going to be 20.1 degrees Celsius. So now I'm going to multiply out all these numbers and just get them all in terms of X. And this is 121,000 calories. So, got some calculating to do. So, 23.1. I don't think you can see that. Let's see. How about over here? Well, it just doesn't look like you're going to be able to see my calculator very well. Okay, 23.1 times 0.50 equals 11.55x plus 80.0x, because there's just two terms. 1 times anything is just that number, so it's plus 100.x, and then plus 540.x plus 0.48 times 20.1 equals 9.648x. Now I'm going to add all those numbers together. So I have this one. I'm just going to work my way back. Plus 540 plus 100 plus 80 plus 11.55 equals. So I have all that equals 741.198x equals 121,000. So now I'm going to divide. So 121,000 divided by second answer equals, so x is going to equal 163.24 grams. And so based on my significant figures, I have 3 here, I have 3 there, I have 4 there, so I need 3 in my answer, so x is going to equal 163 grams. So let me know if that helps. The process that I go through, just to review, is I write out my data and what I need to know. And I probably should have written here also my temperature initial is negative 23.0 degrees Celsius. Temperature final is 120.1 degrees Celsius. And so I know I'm doing some temperature changing as well as some state changing, because this number is below freezing of water and this number is above the boiling. So I know I'm going to have 5 different points. But once I had these 2 temperatures, I drew out what changes of state are happening. So let me know if that helps, and see you in class.